Start. Yeah. Hi everyone. We'll come back to this problem we had the last time. Evaluation of double integrals. We solved this problem already with this solution here. The solution we provided before was splitting this problem into two parts and then combining them together to get the final answer. This is what we have done here. The problem we are given is that we are asked to evaluate the double integral x y to the power of 2 dy dx, where d, this d you see here, is triangle with vertices at 0, 0, 0, 0 is here at the origin, 3, 1, 3, 1 is here, this is the x is 3, 1 here y-axis, and 0, 3, 0, 3 is this one here, 0, 3, the x is 0, y is 3, this one here. So when you are given this sort of information, you should be able to use it to sketch a graph. These sort of problems, without sketching a graph, sometimes it can be very difficult to solve because they come in different ways. Anyway, we use this method of splitting this triangle into two parts because we have two lines. This is line 1, this is line 2 if you want. This line here, we get these lines from this information we are given. We are able to sketch this graph here, A, B, C. So this one you see here, we are looking at this line, BC. It starts, because we have dy, which is our outer integral, and it goes with this integral here, the first one, dy here goes with this. So we want to find the limits. These are what we call limits, bottom limit, top limit. We want to find the limit of dy, because when solving these problems, the outer limit, this one here, it's always, you always have to have numbers here. You see here, you see 3y, 0. You see this is a function, it's an equation. It doesn't bother us. But if this was here, this function was here, then it's a problem. It's a problem. We don't want that. So always try to find numbers here. So that's what we have done here. So these numbers here, this is the limit from 0 to 1 for this line, 0 to 1, because we split it. Yeah? And this one here is from 0 to 3y. This is for the x now. For the x. We solved this already with this format. Now we want to approach it from another format. We want to use a different method of solving the same problem. Instead of splitting it across the y-axis, we now want to cut it through the x-axis. This is going vertically, so we cut it through the x-axis. Yeah? Here we cut through, they are going horizontally, we cut through the y-axis. This is x-axis. What's the difference? Here we split it because of two lines to get the final answer. Here we are not going to split it, we solve it as a whole. So that's the difference. But when you want to solve it as a whole, then you have to do something with this dy dx you see here. You go to interchange them now. Instead of the x coming first, you will now have dy dx instead of the x dy. So let's see. We know this already. Let's solve this one. Same question. just create space. Yeah, so we want to solve this one here. This is 0, 0. Yeah, this is 0, 3, 0, 3, and this is 3, 1. This where they intersect, these two lines where they intersect, if you look here, is 1. This is 1 here. That's why we have here 0 to 1, because for this line, you start from 0 to 1. It's y-axis, start from 0 to 1. Let's forget about that one now. Now, here we are taking the whole thing, instead of splitting it into 2 halves or into 2 parts. We are taking the whole triangle and solve it. So let's find our limits. The outer limits, as we mentioned earlier on, we want them to be numbers. So still, it's gonna be from, for dy here, gonna be from 0 to 3. 0 to 3 this time. Yeah? 0 to 3. And our dx, the inner one, what do we have? We start from bottom to find the bottom limit. We know this line. We know the equation of this line already. The equation of this line. From this information we are given, you should be able to use it to find the equation. You know the equation of this line is this line BC. Its equation is 3y equals x. (3y equals x). Equation of this line here, BC. And the equation of AC x is equals 3 all over 2, 3 minus y. Finding the equation of a straight line is a straightforward method. Use it to find these intervals here. I'm just looking at this interval. I know now here x is equals to 3 over 2 into this minus y. So this is the value of x. That's what I've just written here. From this you can get the value of y. Just do some change of subjects. You can get your value of y. This is the same thing here. This is x is equals to 3y. That is this line here. Its equation is 3y equals x. So this is what you have. Yeah, equation of the lines. So now we want to start from the bottom here. This bottom line up to this top line. So now you will have 3y here and 3 all over 2, 3 minus y. The y, the x, yeah. Yeah. Three over 2, 3 minus y. But then we want the y with this one, and this is the x with this inside one. So what do we need to find here? What do we need to find there? We need to find the value of x because we are integrating with respect to x. So we need x here to find the value of x here, not y. That's the trick. If you don't understand this one, this is in fact a shorter one, and it's easy to handle. This one here, possibility of making mistake is great. So what we are now doing here, you want the x, because we are going to integrate the first one first. This one already comes with number. But now because you have the x here, so we want values of x here. Sorry, values of y here as the limit. So what do? Because we have this top one, this is x equals 3 all over 2 into 3 minus y. This is what it means. So I want y. I want the value of y. So this is going to be now 2x equals 3 into 3 minus y. I've transferred the 2 there. So this is now going to be 2x all over 3 equals 3 minus y. But I want y. So I'll just bring y over there because of the negative sign. So now y will become, this is y now will go there, and this one will come here. So 3 minus 2 all over 3x. So this is what you get for the value of y, which is going to be here now. And for this one, you have x equals 3y. I need y. So I'll just bring the x, the 3 there. So that means now it's going to be x all over 3 equals y. Yeah? So now, because we have done this, I will now put here, instead of 3y, I will put x all over 3. X divided by 3. And instead of 3 over 2 into 3 minus y, I will just put this number here. It's now 3 minus 2 all over 3x. And because we have done this, now these are going to change. This is going to be the y, the x. This is what we got now. The y, the x. So now I can take this off. Take all this off. This is simple, more or less. What we have done here, we just change this integral into this form. Because this is multiplication, x times y squared. If it was like x plus y squared, something else to do with the limits. It's much more than what we have done. It's a little bit demanding what we have done. Yeah. So we now have this. So the whole problem now boils down to this marker keeps boils down to I equals, we have this dxy squared dx dy, which we have now transformed into 0 to 3 and 3 minus 2 over 3x and x all over 3 xy squared dy dx. Dx dy, dy dx, because of what we have done here for this limit. Okay? So now it can easily be solved. We are now integrating this one, this inside one. Yeah? So you still have your 0 to 3 integrating with respect to y. So x is constant. You have your x and this y will now be times 1/3 y to the 3, the x, and you have your values here, your limits here as x all over 3 and 3 minus 2 all over 3x. That's what we got now. Yeah. So we'll move on. 0, 3 x times, I'll just bring this 3 here. So y, this is y cube, yeah? So y cube, you now put this. You now put 3 minus, 2, sorry. 3 minus 2 all over 3 x cube, this cube here, this y, this represents y, the x, no, sorry, minus, now the bottom limit, again, you have x all over 3, this one x all over 3, bottom limit times y cube, this y cube now, which is, yeah, x over 3. X all over 3 cube. Let me just see the x here. Correct? This number, x all over 3, is what I've just put here, x all over 3. But because it's now it's gonna be y cube, but y cube will say is x all over 3. So this is what you have. All that is left now is expansion and collecting terms, simplify, and then you get your final, you integrate again, you get your final answer. So let's expand. You have 0, 3 here. You still have your x all over 3. Expand this. You have, let's do it in a proper way. 3 minus 2 all over 3x squared times 3 minus 2 all over 3x. This is what you have, minus x all over 3. Now going to be x all over 4. 3 times 3, 27 times 3. 27 times 3 is 81. 7 times 3 is 1, 2, 6, 81, yes. All over 81. The x. I split this. 3 minus 2 over 3x to the power of 3. So I have done 3 minus 3, 2 over 3x to the power of 2 times this. So this is still to the power of 3. 2, 1, power of 3. Because we can, this way we can easily able to expand it. So you now have 0, 3. You still have your x all over 3 here. Don't forget it. So now, if we expand this, yeah, you get 3 squared, which is 9, minus twice their product, which is twice their product. You will have 3 times 2 all over 3 times 2. So this will cancel. So this will be now minus 4x and plus 4 all over 9 x squared, and you still have your minus 3 minus 2 all over 3x minus x to the 4 all over 81. The x. Yeah? I need space. So as I go along, it's easy to create more space. So we have this one. Let us now expand this first. You still have your integral here, which is 0 to 3. You have your x all over 3. Forget it. So now 3 times 9, 27. 3 times 4 minus 12x. And 3 times, I'm taking this 3, multiplying everything here. 3 times 4 all over 9. This 3 will cancel this 3. That will be 3. So 4 over 3x squared plus 4 all over 3x squared. Now we come to this minus 2 all over 3. Minus 2 all over 3x times 9. So you get this 3 will go here 3 times. So minus 6x. Minus 6x. Minus 2 all over 3x times 9. So this is 3. So minus 2 is minus 6x. Right here. Where was I? Yes. So minus 2 all over 3x times 4. So plus 8 all over 3x squared. Plus 8 all over 3x squared. Last one. Minus 2 all over 3x times this. So gonna be minus 8 all over 27x cubed minus 8 all over 27x cubed. Minus x to the power of 4 all over 81 dx. This one to what? So now let's see if we can do something here. Yeah, 27. No. So we have our 0 to 3. Let's still put our this one here. Let's simplify now this one. This is 27. Can't do anything about it. This is 12x minus 12x. And this is 4x squared. Oh, 12x. This is minus 18x. This 6x, 12x. This gives us 18x. Minus 18x. This and this. So now x 4 thirds x plus this x squared. So we'll add them 12x squared all over 3, which is 4x plus, because this is 12x, 12 over 3 is 4, which is 4x squared. And then minus x, 8x cubed all over 27 minus x to the power of 4 all over 81 dx. So now let's expand this. This is 3. Let's now expand this x cubed here. X, what this x over 3 we have here. So this is going to give us 27 divided by 3 is 9. So you get here 9x. And this is 18 divided by 3. This is minus 6x squared, because this is x times x squared. So 3 can go into 18 minus 6. You have plus here. This is x cubed all over 4. X cubed, 4x cubed plus 4x cubed all over 3. Yeah, minus 8x going to be x4 all over 3 times 27, 81. And then we have minus x4 all over 81 dx. We're almost there. Yeah? So this gives us 0, 3, 9x minus 6x squared plus 4x cubed all over 3. So here we can do, this is x4, so we can do something here. And this is 81. So this is just minus x minus 8 minus 1. So this will give us minus 9x to the 4 all over 81. But 9 can go into 81 9 times. So this is going to be 1 all over 9 dx. This is what we got. So we can no further simplify. What we do next, we now integrate. We do our last integration. This limit of 0 to 3. So if you integrate 9x, you get 9x squared all over 2. You get 6x cubed all over 3. I'm integrating now, yeah, with respect to x, plus 4 all over 3. Let's put it here. If you integrate this, you get 1/4 x raised to the 4 minus, you have here 1 all over 9 first, forget it. If you integrate this, times 1/5 x raised to the 5 all 0, 3. Now let's simplify. You get here 9 all over 2 x squared. This can go into this minus 2x cubed. This cancels. So plus x to the 4 all over 3. This you cannot do anything here. Minus x to the 5 all over 45 all 0, 3. Again, I need to find space. These problems are long, very long. So now we put 3 in the place of x. So you have here 9 all over 2. Wherever you see x, you put 3 raised to the power of 2 here, minus 2 raised to the 3 cube, plus 3 raised to the 4 of 3, minus 3 raised to the 5 of 45, now minus 0. So anything here, you put 0, we just boil down to 0. So you have 0. So because it's 0 here, if you put in this place of x, you put 0, 0, 0, so everything will go to 0. So we just ignore what comes there. We just evaluate this. So this is 9, 9 times 9, this is 81 all over 2. And this is 27 minus 54. And this is, in fact, this is 27. 3 times 3, 9. 9 times 3, 27. And this one here, oh, this is big. What I could have done This one I can remove this and put 3 here. Yeah. I want to do something. Sometimes mathematics will do a lot of manipulation to simplify things. So I have all 3 squared. So this now, I can take my 3 squared out, and here I will just name with 9 over 2. Here I take, if I take 3 squared here, this will be 2 times 3 left here. Only 1 3 will remain here plus the 2. And this one here, I've taken 3 squared out, 1 3 will remain, and this is plus. This one here I've taken 2 3 out, so I will have 3 to the power of 3 all over 45 will remain here. It's easy to this is easy to simplify. This is minus 6 plus 3 minus 27 all over 45. In fact, we can reduce this further because 3 can 3 can go into 27, 3 can go into 45, yes. So if we take 3 here is 1, 5, 3 here, 27 is 9. So if you take another 3 here, it's 3, 3 here is 5. So you got 3 over 5 here. 3 all over 5. All that is left. This is, bear with me, 3 squared, 9 all over 2, minus 3, minus 3 all over 5. What is left? Yeah? So, if still I can take 3 out. So this will be 3 to the power of 3. This will be 3 all over 2. I'm taking 3 out. Minus 1. Minus 1/5. Yeah? So, so let me do 3 to the power of 3. I want to divide everything by 10. If I multiply this by 5, I will get 15 all over 10. I multiply by 5, top and bottom by 5. This one I will get minus 5 all over 5. Now what I want to do, I want 10 here. If I want 10, multiply this by 5, 15. I want 10 here. So this should be 10 all over 10. So I want 10 and this should be 2 all over 10. So now 15, this is minus 12. So this will give us 3 to the power of 3. So this is 12, this is 3 all over 10. Yeah? This is minus 12. 15 minus 12 is 3 all over 10. So this is what you get. You get, this is a big answer. 3 times 3, this is 81. 3 raised to the power of 3, 81 times 3 all over 10. I don't want to use fraction, so I will just say this is 8.1 times 3. So this is 20, times 3 times is 24.3. This is what I get. Thanks for watching.